Okay, so I turned back all the papers that I have. So you have either still got your 9.3 homework, or I turned it back to you. And this is 9.3 number 1. So 9.3 number 1 says I'm going to roll a die twice, and I want to get a sum of 5. And it's a probability question. We're looking at a homework problem right now, and then we're going to do our notes. So if you already turned in this homework, chances are you missed this problem, because a lot of people did. If you haven't turned it in yet, well, it's fine, it's not due yet. Pay attention. This is the 9.3 number 1 homework. It's the very last problem. And it says I'm going to roll a die twice, and I want to get a sum of 5. And it's probability. So, in the bottom of the fraction, the probability is a fraction, goes what? The total number of outcomes that I can have when I roll 2 die. So I can get a 1 and a 2, a 1 and a 1, a 1 and a 3. There are lots of them, right? How many possible outcomes are there when you roll 2 die? 2 dice, I should say. 36. Why are there 36? 6 times 6. Each die, each one of them can land 6 ways. So the first one can land 6 ways, and the second one can land 6 ways. So together they land 36 ways. Okay, so my denominator is 36. Now, what goes in the numerator? The numerator is what I want to have happen, which is I want to get a sum of 5. So if I roll 2 dice, how do I get a 5? I can get a 1 and a 4. I can get a 2 and a 3, a 3 and a 2, and a 4 and a 1. Aren't those the only way those 2 dice could land and add up to 5? So how many ways is that? 4. So your probability is 1/9. 4 out of 36. Do not get so caught up in C's and trees and Venn diagrams that you forget what basic probability is. What you want over the possible. And sometimes the easiest way to do it is with what we call a sample space. Just write out, this is what can happen. That's it. Okay. All right, so put that aside. If we have time, we can look at more, if there's more homework questions, more things that you missed. But first we have to cover some more ground here, because we're talking about sequences. Yesterday we had a couple of formulas, and I told you, I think I told you, that you don't have to memorize these. They'll probably get memorized just because you use them over and over again. But you have, even though you don't have to memorize them, you have to know that this one is associated with arithmetic sequences, and this one is with geometric sequences. So, when I look at problem 1, I'm in 9.4 notes. Yesterday we discussed vocabulary and we got the formulas. Now we're looking at the problems. Number 1, consider this sequence. Tell what type it is. Choices are arithmetic, geometric, or neither. So this one is definitely arithmetic because what's happening? I'm adding 4. So it's arithmetic and the common difference is 4, right? Give an explicit formula. This is an explicit formula. This is the explicit formula for every arithmetic sequence in the whole wide world. I want the one that goes with this sequence. So, for this sequence, what does that mean right there? What's that? First term. Your first term is 3. Your common difference is 4. There is your explicit formula. Now we're going to clean it up because we do have some distributive stuff going on. But that's it. I plugged in my first term and my common difference, and now it's special to that sequence. So what have I got? 3 plus 4n minus 4. Looks like it's 4n, oops, that's 4n minus 1. Now what does it mean to be an explicit formula? It means that if for some reason you want to know the 500th term of this sequence, you can find it. Because if you want the 500th term, you're going to let n be 500. So that's going to be 4 times 500 minus 1. So what is that? 1999? Done. Got it. Now, give a recursive formula for the same sequence. Okay, let's think about this for a minute. You may not know what recursive is, but you're going to know in a second. If I said to you, Kara, what is the next number that goes in this list? I bet you're not going to use this formula. I bet if I ask you for the next number, you're going to say 19. And how did you get 19?
I just saw that you were adding 4.
You took this one, 15, and added 4 to it. So 1, 2, 3, 4, 5. This was the 5th term. And you said the 5th term is simply the 4th term plus 4. Would everybody agree with that? That's what recursive means. Recursive means you take a term wherever you are right now, and you do something to that term to get the next term. So would you agree that the 6th term will be the 5th term plus 4? So now I have to like generalize that. In other words, put some n's in it. So let's see. Take a look at what Kara did, and then what I did. If I take some term, some nth term, and add 4 to it, what will I get?
Yeah, that's my calculus.
What will I get? A sub n plus 1?
Thank you.
1 more than what I had before? This is a recursive formula. It says that if you take the 8th term and add 4, you get the 9th term. If you take the 62nd term and add 4, you get the 63rd term. Now, the only thing about these guys is you have to tell me where to start. So I have to add that the first term is 3. Because all this formula does is tell me that I keep adding 4. If I don't know where I'm starting, then I can't do that. I need to have a starting point. So start with 3 and keep adding 4. That's what this says. Now, I'm not a big fan of these. They're necessary, but I don't like them very much. Because suppose I want the 500th term using this formula. Well, how would I do that? How would I get the 500th term using this formula? Be the 499 plus 4. Now, that's true, but where do I get the 499? The 498? Do you see what's wrong with this? I'm not going to be able to jump straight to the 500. I'm going to have to literally keep adding 4. So these guys, while they are necessary sometimes, they're not nearly as handy as the explicit ones. All right, let's try B. What's happening in sequence B? Arithmetic or geometric? geometric with a ratio of, what am I multiplying by? Negative what? Negative 1/2. Aren't I multiplying by negative 1/2, guys? Ratio can be anything. Negative, positive, fraction, doesn't matter, anything. So it's geometric. My formula says that the nth term is the first term times the common ratio to the n minus first. Done. That's it. Please do not ever combine these two. See how that one has an exponent and this one doesn't? Please don't put them together. Don't combine them. Just leave it, just like that. That's your explicit formula. So if you wanted the 15th term, I'm just randomly saying that. If you wanted the 15th term, could we find it? Yeah, it's negative 2 times negative 1/2 to the 14th. And I would just type that in my calculator and I would have it. Now, how about a recursive formula? If I take some term, just some general term, what do I have to do to it to get the next term? So in other words, if I had 1, 2, 3, 4, I have the 4th term. What do I have to do to this guy to get the 5th term?
Divided by -2.
Well, either divide by -2, or in sequence land, we don't really divide, we multiply. So if I take that term and multiply it by -1/2, I'm gonna end up with the next term. So the 4th term times -1/2 will give me the 5th term. Don't let the subscripts bother you. If that's 4, that's 5. These are just consecutive terms. And don't forget, in the recursive formula, we need a starting point. So our first term is -2. Okay? Now, before we go to the next problem, I want to talk about a very special sequence. Have you ever heard of the Fibonacci sequence before? Have you ever heard of Leonardo Fibonacci? What context have you heard of it?
Squares.
Okay, maybe, I'm not familiar with that, but very well could be. Probably is, I'm just not familiar with all of them. There's a whole book in the library about Fibonacci. Well, here's the Fibonacci sequence. Now, you know me well enough by now. I do not have that memorized. I cannot memorize anything. That is not memorized. There's a very special pattern happening there. It is not geometric and it's not arithmetic, but there's definitely a pattern. What's happening? What'd you say?
Go back one and add it to the next.
So Peter says that if you add these two together, you get that one?
Yeah.
And if you add these two together, you get that one. So in order to get the next term in this list, I would add these two. So the next term in the list is 89 and so on. All right? Now, that's recursive because in order to get this term, I had to know what these two were to add together. There's no shortcutting it. So what will the formula look like? It's going to be something like this. How did we, okay, let's see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is going to be the 12th term. How will I get the 12th term of this sequence?
Term 11 plus term 10.
Exactly. I'm adding the 11th and the 10th. in either order, doesn't matter. So now let's put n's in there. The smallest number is 10, so I'm gonna let that be n. So a sub n is getting added to what? What's this?
A plus
A sub n plus 1?
1. Already got
And what's that gonna give me?
A sub n plus 2.
Exactly. That's the formula for the Fibonacci sequence. Remember, n plus 1, n plus 2 are consecutive numbers. So if this is 5, this is 6, and I'm adding the 5th and the 6th to get the 7. Don't forget though, you always have to add your starting point. And for Fibonacci, since you're adding these two, you have to give me 2 to start with. Could we have that pattern, but generate a different sequence if we started with different numbers? Sure, it takes both. If this is the sequence you want, then you need the pattern and you need to know where you're starting. Okay? All right, now we're ready for C. That's just a little side note that you know what Fibonacci is. It's all over in nature. Next time you're out tromping around the woods, pick up a pine cone and just hoping it hasn't been damaged. If this, you know how they have kernels coming up, you know, the little kernels and the layers of them. If this layer of kernels has 21, the one right above it will have 13, and the one above that will have 8, and so on. Bee honeycomb, you ever seen a honeycomb? You know, the actual thing they take the honey out of? Same thing. Sunflowers, go out and see the seeds in a sunflower, assuming it hasn't been damaged. If the one ring has 5, the next ring's gonna have 8, the next ring's gonna have, and so on. It's that pattern. It may not be those exact numbers, but it's that pattern. It's really cool. Math is wonderful. Okay, let's look at the next sequence. Alrighty. Now, luckily, we don't need to find a recursive pattern for this. We just need to find some kind of, what the heck's going on? We need to have a formula for this kind of crazy sequence. Does anyone notice anything about this set of numbers? It's kind of tricky. No? Well, throw out an idea, get us started.
Plus 5, plus 7, plus 9, plus 11, plus 13. Plus
Okay, is that what's happening? I haven't checked.
Yeah.
Is that what's happening? Okay, so you've definitely found a pattern, but now your job is to write a formula for that.
You guys, you're gonna teach us, right?
Well, I'm not gonna do it I'm not gonna use that particular pattern. I see another pattern.
Okay.
That would be yours is harder, Jake.
Okay.
That's okay, just harder. Why are you two like reclining? Sit up.
I was laying here first.
Get up there, get up.
I'm answering.
I know you are, but I don't care, sit up. If someone walked by and saw that, they would think that I'm not engaging.
And they'd hear me calling out all these answers up here in this floor. Like,
I don't know why you're so tired, stop it. What were you gonna say now? Were you gonna say something?
But I keep thinking I see something and then not seeing it.
Would you add 1 to all these numbers? Just go through and add 1 to all of them. Then do you notice anything about them?
Oh, square.
They're the squares. Because if you add 1 to all of these, don't you get the squares? So isn't this, for example, isn't the first term 1 squared minus 1? And the second term is 2 squared minus 1? 3 squared minus 1? So the nth term of the sequence will be n squared minus 1, isn't it? That's your explicit formula. Now that we have talked about that, I caught you off guard, totally, I get it. But now that we've talked about it, you're gonna kind of be on the lookout for what we call special numbers. The squares are special numbers. So are the cubes. If you have a problem with 8 and 27 and 64 in it, then you better be zeroing in on the potential, at least, of having cubes. You see what I'm saying? So there are these groups of special numbers that you just kind of want to be on the lookout for. All right, number 2. Find the first 3 terms and the 50th term. Well, there's nothing tricky about this. The formulas are given. They're written kind of differently maybe, but they're given. If a sub n is n plus 1 over n, what is a sub 1? This n and this n and this n are all the same. So what's a sub 1? 1 plus 1 over 1, which is 2. What's a sub 2? You guys are making it hard on me today. That number there is the same as these. So if that number's a 2, then you're going to have 2 plus 1 over 2. And I need the third term. It says find the first 3 terms. What's the third one? 3 plus 1 over 3, 4 thirds terms. And then for some reason it skips ahead and says find the 50th. What's the 50th?
50 plus 1 over 50.
So 51 over 50? Don't make it hard, that's so easy. How about the next one? A sub n equals 4 over n plus 2. I need first, second, third, and 50th. So what's the first one?
4 thirds.
4 thirds?
1.
Wouldn't the next one be 1, because it's 4 over 4?
fifths.
Next one will be 4 fifths.
4
And the 50th is 1/13. We're going to reduce that. 452 is 1/13. Number 3. Last one. We're going to get through number 3 and then we'll be done for the day. Is the sequence divergent or convergent? I don't know if we've had those words before or not. Divergent means there's no limit. It means the sequence isn't approaching something. It's kind of. Convergent means that as you go from term to term, you get closer to something. So I want you to look at problem A. Would you say that's diverging or converging? Problem A. Diverging? Because what's happening? It just keeps getting bigger. Exactly. It keeps getting bigger. So that is definitely diverging. What about B though? What are those numbers doing? They're getting smaller. So the limit, somebody said it, the limit is 0. Because they're getting smaller, but will they ever be negative? They just keep getting closer to 0, so the limit is 0. C. Now, do not freak out. You have seen this exact problem before, but the vocabulary was different. The last time you saw this problem was in the last chapter, and it looked like this. And I said to you, where's the horizontal asymptote? And you said to me, the horizontal asymptote is 3. The horizontal asymptote is the limit. So the limit of that guy is 3. For exactly the same reason as that was the horizontal asymptote. That's 3. So what about D? What's the limit? It's convergent, and its limit is -2. What about E?
4 fifths.
4 fifths. Kids, are you connecting this to what we did before? Now, what about F?
0.
0. The limit is 0 because what are we missing? An n squared on the top? G. Stay with me, guys. I promise we'll be done soon, but we gotta get through this. So what about G? Problem G. What, Kara? There is no limit. It's divergent. Why is there no limit for problem G? Because there's no squared on the bottom. And remember how we had to do that, guys? We had to put a 0 in squared so that we can compare those. What's 8 over 0? Can't do it. So that one's divergent. Number G is divergent. Now, H through L they look different. They're not ands or brands, they're a whole different ballgame. What's happening in letter H is that we keep multiplying by 2/3. So the first term is 2/3 to the first, the next term is 2/3 to the second, and then 2/3 to the third, and so on. Tell me what happens when I keep multiplying by 2/3. You're getting smaller, aren't you? Will you ever be negative?
No.
You're just gonna keep getting closer and closer to 0. Your limit is 0. Does it make sense to you? That was a 2/3. But what if it had been a 3/4? Would it still be 0?
Yeah.
In fact, as long as that number right there is less than 1, isn't it always just gonna keep getting closer to 0? So when I look down my list here, look at letter K. I don't care what the exponent is. That's 0.36. What happens when I keep multiplying by 0.36?
Goes down.
Goes down. So K, the limit is 0. H and K are both 0s. Now, I, J, and L. And again, I'm not hung up on the exponents. It's that base number that matters. In letter I, now I'm multiplying by 3/2 or 1.5. And what happens when I keep multiplying by 1.5? Amanda says, it gets bigger. That's divergent. What about J? Divergent. What about L?
Divergent.
Divergent. So those kind of problems that are something to the nth or some kind of power, you're either going to go to 0 or you're going to be divergent. And it depends solely on the size of the number in the parentheses. Okay? Oh, David.